So in this video, we're going to start looking at parallel lines cut by a transversal. So in these diagrams, you can see we have two blue lines that are parallel. Parallel means the lines will never come together. And then they're cut or crossed by this other red line that we call a transversal. And that just means that it crosses both of these lines. So when this happens, we have a couple relationships that we want to recognize. So the first one we have here is alternate interior angles are a pair of angles that are between the parallel lines. That's what interior means. And opposite sides of the transversal. That's actually what alternate means. Alternate interior angles are congruent to each other. So if we look at the diagram here, we can see they're inside the parallel lines, meaning in between. So we have the 4 and 6, those are the red ones here. And then we have the 3 and the 5, those are the purple ones here. So I know on your paper it might not be quite perfect there, simply because they aren't going to look terribly different colors. But you can see the wording too, just in case. So it's showing that angle 4 and angle 6 are alternate interior angles. Angle 3 and angle 5 are alternate interior angles, just in case the kind of coloring is lost there. So we can see that 4 is on the left side and 6 is on the right side. So they're on alternate sides, they're on different sides of the transversal, and they're both inside the parallel lines. So we can see the same thing with 3. 3 is on the right, 5 is on the left. Alternate sides of the transversal, but still inside the parallel lines. So these are alternate interior angles, and they are always congruent. As long as we have parallel lines, they are congruent. So we have a very similar property down here. It's alternate exterior angles. So if we just think about the wording, the way this one was worded was alternate interior angles. So they were on different sides of the line, but inside the parallel lines. So now if they're alternate exterior angles, they're still going to be on different sides of that transversal, but now they're going to be outside of the parallel lines, right? So let's go ahead and confirm that. So alternate exterior angles are a pair of angles that are outside the parallel lines and on opposite sides of the transversal. So exactly what we thought. Alternate exterior angles are congruent to each other. So they share that same property. They're both congruent. If it's alternate interior or alternate exterior, they're congruent. So we can see here I have 1 and 7, which is stated down here, if you can't see it in green. And we have 2 and 8, which are in blue on my slide here. But if on your paper, when you're looking at it, it's also stated up here for you. So we can see that 2 is on the right, 8 is on the left, and now we're just going on the outside of the parallel lines. They're not in between, they're on the outsides. 1 is on the left and 7 is on the right, and they're on the outsides of the parallel line. So these are the first two properties. We have one more that we're going to pay attention to, which is called corresponding angles. So corresponding angles, it's one that holds the same relative position as another angle somewhere else in the figure. So corresponding angles, you kind of want to think about it if, like, I'm focusing on this top left. Well, it's on top of its parallel and it's to the left of the transversal. So I want to find another angle I could describe that same way. So if I go to the other parallel line, I want to stay on top of the parallel line and to the left of the transversal. So I find this little blue one here. So it would be this green and this blue. Or I could do the same thing with this green one here on the right side, because it's on the top of its parallel to the right of its transversal. So I do the same thing on the other one, and I go, well, this blue one, it's on top and to the right of the transversal. So it's just, I want to be able to describe them the same way. Are they in the same relative position? That's what that means. This is another way of looking at this. I like this one because you can actually see the angle measures. So this is just an interactive piece that I can move the parallel lines around, and you can see the lines stay parallel together on this function. I can also move the transversal around, and if you're paying attention, these are corresponding angles because they're both on top of their parallel lines and to the right of the transversal. So it looks like I could just take this one and slide it right down. I know there are some of these that I could actually bring it together to show you that I could literally take this one and it looks like it would slide right down and it would fit right on top. But no matter how I move these, the angles are exactly the same. Whether I move the parallel lines or whether I move the transversal, I can move it and I can even flip it around so it's the other direction here. So that's going more than 180 because I went backwards. So it's going, all the way around like that. But we can see that they're matching. So now I can do alternate interior angles so we can see they're in between the parallel lines. And again, no matter how I move this line, they will stay congruent. Or I can move the parallel lines and they're going to stay congruent to each other. Same thing with alternate exterior angles. So they're on the outside of the line but opposite sides of the transversal. So again, you can see how no matter how I move these, we will have parallel or congruent angles. So I just like that interactive because it's a very nice way of being able to see how that measure changes. So we're going to go ahead and we're going to apply what we just learned to this problem. Now in this problem, hopefully you can see this, the two lines going left and right are not parallel, right? So they look like they're getting farther apart here. They look like they're getting closer together on this side. So they're not parallel. So the properties of being congruent are no longer true. We still name them the same way. Corresponding angles are still in the same relative position. Alternate exterior angles are still on alternate sides of the transversal. And outside of the parallel lines, or interior angles are, inside on alternate sides. So we still describe them the same way. They just don't have those special properties of being congruent. Okay, so we're going to go through and we're going to name. Now keep in mind there are a lot of different angles I could choose from. So for corresponding angles, remember that's the same relative position. So I could look at 1 and 3 because I'm on top of the parallel lines and I'm to the right of the transversal. Or I could look at 5 and 7 because now I'm just to the right of the transversal, but I'm still on top of the parallel lines. Or I could go below the parallel lines and stay to the right on each side of the transversal. So that's 6 and 8. Or I could do 4 and 2 because this is just on the left side of the transversal, but underneath the parallel lines. So these are all considered corresponding angles. Any pair of these, so you choose one of the 4 here, and that would be an appropriate answer. So 1 and 3 is not the only answer. I could go with 5 and 7, 6 or 8, and 2 and 4. So I would just choose one. All right, the next one, so we're going to look at alternate exterior angles. So with this one, it animated a little quickly there, but you can see I chose 1 and 8. So they're on the outside of the lines. They're not parallel lines this time, but they're on the outside of the parallel, the two lines, we'll say this time. And they're on alternate sides of this transversal that's crossing the two lines. So we could go with 1 and 8, or I could go with 5 and 4. So those are my two options. I only have two options here because since it's specifically alternate exterior angles, I have to stay on the outside, and they have to be on alternate sides. So I only get two options there. And the last one is alternate interior angles. So now I'm just moving inside the parallel lines, or the lines. So I have 6 and 3 because they're on alternate sides, but inside. Or I could do 2 and 7. So lots of different options there, but that's kind of the beginnings of parallel lines in a transversal. I hope that helped, and I will see you on the next video.